Hello, my name is Jimena, and my allocated research project was the Adirondack Mountains. So, just to begin, we need to know where these mountains are. So, their geographical extension goes from the Mohawk River to south of the St. Lawrence River Valley. So, that's just a recap of the information. And that is an area of the Adirondack Mountains. It's a map. You can go there. It's a park. So before we begin, it is in order to understand why the Adirondacks have the characteristics that they have, or why they are different from maybe other mountain ranges, or why they have certain rocks. It is important to understand the possible formation mechanisms that help form these mountains. And in conjunction with that, it's also important to know the mineralogy, because the mineralogy aids us in unraveling more clues. For example, some rocks may be older than others, so we can see what areas took shape first, and different chemical compositions of the rock may also help us in knowing what specific tectonic event helped form that rock, or the weather conditions 1,000 years ago, whatnot. So, the oldest rocks in the Adirondacks date over 1,000 million years ago, and the youngest are around 5 million years. So the region where the Adirondacks are located used to be conformed mainly by glaciers. So there were different tectonic events, and then we know that the climate changed over time on Earth that made a shift from glaciers to what we know to be the Adirondacks today. So those are some glaciers. So what the glaciers do is, when these tectonic events happen, ice and glaciers are moved around. They uplift the soil. They get rocks with it. These rocks change, and they form. So sometimes the ice would get so great that it would actually be higher than the height. It would actually be taller than the mountains itself. And then, well, with these different events, the Adirondacks began to form. So there are also different theories of how the Adirondacks formed, or what mechanisms helped form them. And one of the explanations is the Proto-Rosaic rifting, was that dikes in the Adirondack show similar characteristics to those in the East African valley systems, and this was determined by the types of rock that were found. And the picture on the background of my PowerPoint, you can actually see the African rift system, which is a divergent zone, subduction zone. And then there is another hypothesis that two scientists made, that there is actually there is a speed pillow, and it's actually underground. So this speed pillow is under lots of pressure because of the asthenosphere, and when this happens, this ball just goes under so much pressure and it begins to upwell, and then it eventually radiates out heat, causing thermal expansion and causing dikes and causing movement within the surface. And one of the explanations is also that they could be connected to a larger anomaly. And before we move on to mineralogy, something that I did not include in my PowerPoints here was it's really unique. There is they say that the Adirondacks could be connected to the Himalayas, because it is the only place on Earth where they have found a crustal zone to be 65 kilometers deep. So the crustal thickness of an area of the Adirondacks is 65 kilometers deep. And the only place on Earth that has something similar to that is the Himalayas. So there is another hypothesis saying that some time ago, that the Adirondacks could have been even as tall as the Himalayas, which I think is pretty cool. And so as I just explained, there have been different changes in the landscape and events, and all of that has changed the mineralogy over time, because rocks will not stay the same from 1,000 years, from tens and hundreds of thousands of years ago till today, because there are different, we know there's weathering, we know there is different changes in climate, whatnot. And these changes that the rocks undergo, when we study the rocks, we can see what changes could have taken place, and we can understand what could have happened in the region with further detail. So those are some rocks in the Adirondacks. The one in the right has fossils, I think. So, mineralogical information about the Adirondacks. Many rocks have found to have ortho-inclinopyroxene in the northeastern parts of the Adirondacks, and there are different. There is rocks that are from the amphibolite species, and that can also be from the granulite species. There are also, like, in terms of rare earth minerals, one rare earth mineral that has been found to be in the rocks has been apatite, and it is said to come from gneiss protolith as well. Like, it is common to see the gneiss protolith in the Adirondacks. And, well, there is still many unknowns regarding the Adirondacks, because we know that technology and data collections are still not advanced enough. There are many setbacks regarding this, but this is the tip of the iceberg of what has been collected so far, and that is my conclusion. I thank you for listening.